Hello, everyone, and welcome to task number 7. In this task, we are going to compile and train our deep neural network model. So let's get started. If you guys remember in the previous task, in task number 6, we have been able to build our residual neural network from scratch. So we actually used Keras API to build our network. We built our res block, and then we called it here several times to actually build our full network. And we actually built a network of around 5 million trainable parameter, which is pretty amazing. So in task number 7, what we're going to do, it's actually pretty straightforward. I'm going to compile my model. So I'm going to specify what type of optimizer that I'm going to use, which is Adam Optimizer. And it actually worked really well. The actual details of Adam Optimizer is beyond the scope of this, I would say, 1 hour case study. But you guys can do just a quick Google search to understand what's happening with Adam Optimizer. And here for the loss, we are going to specify its categorical cross entropy, because simply here I have multi-class classification problem. You guys can use binary cross entropy if the problem is just binary classification, like if I have only 2 classes. The metrics will gonna be accuracy. So if you actually run that, if you press Shift Enter, that simply will compile my model. And then next, what we're going to do is that I'm going to specify here that we're going to do what we call it early stopping. Simply, I'm going to use patience equals 15, which means that I have to make sure that as the model is being trained, that the model is not overfitting the training data. So I'm going to set patience equals to 15, which means I'm just going to be patient. And as long as the validation error does not exceed the training error, then I'm good. Okay, then that's a good thing. That means the model, both errors are actually going down, which is great. Okay, or both losses are going down. However, once I see that there is a problem where the loss on the training data is going down, however, the loss on the validation data, which is cross-validation data set, is going up, that means there is a problem. That means the network starts to essentially overfit the training data. And if that kept going for several number of epochs, then I have to intervene and actually have to stop the training somehow. And that's what we call it early stopping. Next, I'm going to create what we call it model checkpoint. I'm going to essentially save the best network weights, and I'm going to save the weights in a form of HDF5, and that's the extension where I actually save the frozen weight. I can think of it as this is kind of a snapshot in time where this is the best model that I have, so I'm just going to save it. And that's it. When I run these 2 cells, okay, looks good. Now what I could do next is I can apply the fit method to my object, which is my model, pass it along here, my training data generator. If you guys remember, we created that before. Here, I'm going to simply specify how many epochs I need. So please note that just for the sake of demonstration here, or for demonstration purposes, I'm just going to be using 2 epochs only. Actually, I'm going to use even like 1 epoch only. And afterwards, if you guys can see, if you guys scroll down here, I've already included for you guys a model which is called retina underscore weights. And this model has already been pre-trained before. So it's already working and it's already doing, around 85% accuracy or so. So I'm not going to be training the entire model here. I'm just going to show you guys that it's already doing a single epoch. And that should conclude this task. And in the next task, I'm going to load that model. And actually, if you guys go back to this main page, you should be able to see here it's called retina underscore weights, and you should be able to just load these weights right away. Otherwise, you guys have to wait for, I would say, maybe 6 or 7 hours for that model to train. And then here you need to set the number of epochs to maybe 20 number of epochs or so. So let's go ahead and run that. If you press Shift Enter, should be able to see that now we are actually feeding in the training data to my model, and we are actually training it. Afterwards, I'm going to simply plot here the losses for the training data and for the validation data. And that here, if you press Shift Enter, that here, after this cell is run successfully, I'm going to see the plots for both of them. And we are going to go through mini challenge number 5, where I'm going to ask you guys to try a different optimizer and perform retraining to the model, and also change the value of patience in early stopping and see if that maybe impact the performance of the training. But please note that this again will take, to actually see a difference, you actually need to change the number of epochs to maybe like 10 or 15 or even 20 to actually see results. So that will take, again, way longer time. And I recommend that maybe you guys can, after you go through Rhymes virtual machine, you can actually download maybe a sample of that model, and then you can run it, for example, on a GPU, for instance, and that will accelerate things quite significantly. So as you guys can see here I have the train for 77 steps and validate for 13 steps. And now again, you should be able to see epoch 1, and you should be able to see some progress bar that shows you the actual training progress throughout the entire epoch, where we actually feed in all these different images and update the weights. All right, so as you guys can see here, now the actual progress bar appeared here. It's showing you the loss, which is at 5.9, and it's showing you the accuracy, which started at around 0.39 or like 40% accuracy. And you should be able, if you let the actual training go maybe to, again, 5 or 10 epochs, you should be able to see that accuracy is actually going up. And you guys, as you guys notice, it's actually going up to 42% right now, which is pretty good, given that we're just feeding in the images for the first time to the network. Okay, all right. So what I'm going to do is just going to pause the video, and I'm just going to be back once the first epoch is complete. All right, so as you guys can see here, epoch number 1 is complete. And you guys will notice that the accuracy reached around 63%, which is actually pretty good given that it's just one single epoch. And if you guys can see here we have been able to, obviously because we only have one single data point, you can't see much here. But if you guys extend this plot to maybe, let's say 10 epochs, for example, it might take a couple of hours, but you should be able to see it, the training loss and validation loss starting to go down here over the series number of epochs, essentially. And for mini challenge number 5, what I'm asking you guys to do is to please go ahead, pause the video, and I want you to try a different optimizer and try to retrain the model. And I also want you guys to change the value of patience in early stopping. So please go ahead, give it a shot. Again, it might take, I would say, a couple of hours for it to train. So if you guys wanted to maybe finish, if you would like, the next task, so we can actually finish the entire project with a pre-trained model, and then you guys can maybe try different optimizers, different, let's say, values for patients, and so on. You can do that after the next task. You guys can go ahead and you choose. So just going to go ahead, I'll give you guys a chance to pause the video and attempt to solve the mini challenge on your own. And then I'm going to be back and finish right away task number 8. So I will see you guys after the mini challenge. All right, I hope you guys were able to figure out the challenge. So if you guys scroll down here, you should be able to see in mini challenge number 5 is that you can maybe change, instead of Adam optimizer, maybe you can run NDAM optimizer. There are so many other optimizers that you guys can leverage. And you can change also the value for patients to maybe 25, maybe to 35, or maybe a little bit less, and then give it a shot and see how would that impact the performance of the model training. And that's all I have for task number 7. I hope you guys enjoyed it. In task number 8, let's go ahead and assess the performance of our trained model. So please stay tuned, and I will see you guys in the next lecture.